All right, we are going to use that isosceles triangle theorem that we learned in our last example with a real life word problem. So let's kind of see how this might come about in your daily life or the daily life of an architect. An architect is designing a community park between North First Street and South First Street. So if we look at our picture, we can see here's North First Street and here's South First Street. So we are designing a community park between those two. The pathways on either side of the pool will be equal in length and will provide effective access and circulation around the pool. So we can see in the picture, it has been designated. I'll make it a little bit darker. Here's our equal length. So those two sides will be equal length, makes them congruent sides. To protect the landscaping and to minimize erosion, the architect will place a triangular section of triangular cobblestones at the corners along Park Plaza. So at the corners along Park Plaza, so here we have corners D, E, and F. What angle measure should the architect specify for the corners in her design? So if we look at the picture, we can see that we have two congruent sides of a triangle. So this is an isosceles triangle. If you have an isosceles triangle, the angles opposite each side will be congruent. So the angles opposite is going to be this angle is going to be congruent to this angle. So I'll just say angle E will be congruent to angle F. So how can we figure out what angle E and angle F are? That's what we're being asked. So if we look at the picture, we've got a triangle and there's another piece of information that will get us there. Angle D has been measured out at 50 degrees. So what do you remember about the angles inside a triangle? If you remember, they add up to 180 degrees. So let's take that 180 degrees, subtract out the 50 degrees that we already know. That leaves us with 130 degrees left over for angles E and F combined. Because E and F are congruent angles, we can take that 130 and divide it by 2, so we get the same size angle, and we're going to get 65 degrees for angle E and for angle F.